So we have talked about how to perform addition between two operands. Many a times you have immediate value, like in the loop. When you have to increment a loop, what do? If the loop variable is I, what you do is I equals I plus 1 in every iteration. So 1 here is an immediate value. So it's a constant data specification instruction is like this: a equals a plus 4, incrementing by 4. Okay, so there is a specific instruction for this, which is called add I. I corresponds to immediate. Okay, there are many instructions like this you will see coming next. So I always corresponds to immediate value, which means that the second operand will always be a constant value. It will not be any register. Okay, so design principle, again, third one, make the common case faster. So small constants are very common, just like incrementing a variable. So instead of reading the data from the register, we incorporate the immediate value within the instruction. Immediate operand avoids a load instruction also. Load instruction, we will be discussing that probably after your quiz. But the load instruction's purpose is to load the data from memory into registers. Okay, so whenever we have to perform immediate operation, we use add I instruction for addition. Similarly, sub I for subtraction. Okay? Yep.
So in this case, the second value that you're talking about that's constant, that's the 4. Right?
That's the 4, yes.
And then A is the immediate value?
A is the register, the variable, which is assumed to be x22 in this case. So x22, so value of A is stored in x22. So what this instruction will do is will go to x22, grab the value, maybe let's say it contains a value 10, and then it will increment it by 4, which will make 14, and then will update the same value into the same location, x22. Now x22 will be 14, and next time this instruction will be executed, so it will be 14 plus 4. Okay? Any other question? Yep.
I still don't quite get the difference between the regular add and the add immediately.
So in the regular add, you have two register operands, two variables.
Sure. Okay, yeah.
Okay, so two variables means like it has to go to first location and then the second location and grab the contents. Here it has to go only one location and the second operand is immediately available.
Okay, so you couldn't say add, you couldn't put just like a number there like 4, and you couldn't use the add like instruction?
Add I.
If you did, no, but I'm saying if you tried to not do the add I, if you just said add and then you put 4, like would that just...
We cannot. We are not allowed to put any constant value with the simple add instruction just like this. So add has, if you're using add, then we have to specify both operands. Okay. And add I itself corresponds to the immediate value, and it must be the second operand. The constant value must be the second operand. Yep.
So add I is only used to increment? Or does it have other uses?
We are incrementing the same variable. It could be something else, like add I. It could be, let's say, if I were to write it quickly here, it could be A equals B plus 4. In that case, let's say add I x22, x23, and then 4. So there are two different registers. We are not incrementing in this case. They are just adding an immediate value. Incrementing is this what we are doing it here. Okay? Any other question? Good.